Good morning. So today we're going to cover using logarithms to solve exponential equations. Topics are solving exponential equations using logarithms and power property of logarithms. Sorry, sorry for yawning. Okay, definition of logarithm. Basically, if you have the exponential equation y equals b to the x, it's equivalent to x equals log base b to the y. And remember, the logarithm key on your calculator is a log with a base 10. And if you have a log that doesn't have a base, like log x, that means it's log base 10 of x. This is because, for like science and just like our, like our purpose, like our number system is a base 10 system, right? In scientific notation, right? You rewrite everything as it's base 10. And so that's why like the common base is base 10. Okay, let's do the exploration of a logarithm of a power. So we're going to determine whether these equations are true or false. So here are the equations. This first one we can do without a calculator. We just need to rewrite the insides of the parentheses as powers of the bases of the log. So for instance, like 25 is 5 squared, and then 5 can be written as square root 25. So that's log base 5 of 5 squared is equal to log base 25 of 5 to the 1/2. So remember, the square root of 25 is equal to 25 to the 1/2. And so if you have log base log the same base as the power, right? Those cancel. So the right side is 2, and then the left side is 2, and the right side is 1/2. So this is false. And for the rest of them, like B, C, and D, you have to graph the left and right side because you have X there. And to do that, you just like graph them, and then if the graphs are the same, then it's true, and if they're different, then it's false. So if you graph log of x squared, so remember log without a base is log base 10. So the left side, it looks like that. It's a pretty cool graph. And then if you graph the right side, so again, remember, we're looking for the same graph if they're true. You get this. So they're not the same, so a statement is false. Okay. Okay, so this is important. Like basically log of x squared with x squared inside is different than if you just square the log, right? Like you're getting totally different things. This is basically like proving to you, the point of this exploration is like to prove to you like certain properties, like A, right? You cannot like just switch the inside of the parentheses and the base and have them be the same. Like log base 5 of 25 is not the same thing as log base 25 of 5. And then you can't just like, again, for B, you can't just like square the whole log and think it's the same as log of x squared, right? So these are important properties. Okay, now this one is log of 7 to the x equals x times log of 7. So if you graph log of 7 to the x, actually get a line. And if you graph the other one, you actually get the same exact line. This is true. Okay, so this is important. So that's weird. So basically what happened here? Log of 7 to the x equals x times log of 7. Looks like the exponent came down and it multiplied. All right, and then the last one. So again, let's look at this equation. It says log of 2x equals log base 2 of x. So can you just move numbers to the base and get the same thing? So left side of the equation, the graph looks like this. Oh my gosh, I keep yawning. I'm sorry. I hope this isn't like super annoying. Okay, and then the right side is it. So you get different graphs. So this is false. So you can't just move the number to the base. All right. So the only thing that happened that was true was C, and that brings us to the power property of logarithms. So the power property of logarithms says if you have log, and it just says this log base 10, but it's actually any base. So if you have log of a power like m to the n, you can take that exponent down and then you multiply. So it's n times log of base m. So some examples with numbers. So if you have log base 3 of 9 squared, it equals the same thing as 2, which was the exponent, times log base 3 of 9. Log base 2 of x to the 4th, you bring down the exponent, it's 4 times log base 2 of x. So like I said, it could be any base. Okay, so this is an important property that's going to help us kind of with the next thing. Okay, so we're going to go into solving exponential equations. So we're going to go over 3 different methods. So this method 1 is the graph, which is the way that you learned beforehand. So if you have this 1.04x equals 2, right? You can't make them have the same bases. So what we learned was to solve by graphing. So just kind of go over the steps again. So this is the way that we learned like really early on, at least in my class, right? About how to solve like weird equations by graphing, right? You put the left side of the equation in y1 and the right side in y2, right? So here's your graphing calculator, right? You put the left side 1.04x into y1 and the right side in y2. Right, and then for the purpose of this problem, it'd be nice if you like do this with me, but you know, you don't have to. But for the purpose of this is you want to have this be your window, and then your graph should look like this. So remember, so once you graph the left and right side, right, you want to adjust your window, and I just did it for you, but you want to adjust it so that you can see the point of intersection of the two graphs, right? So I can see my point of intersection there. And then once you can see your point of intersection, that's what you're trying to find. You're trying to find the point of intersection, and then the x value of your point of intersection will be your answer. So remember, to find the point of intersection, you press second trace, and then you get this screen, right? And then you want to go down to 5, which is highlighted there, to intersect, right? And then it's going to ask you a couple questions, right? It's going to say first curve on the bottom of the screen of the graph, right? And then you're going to say yes, so you press enter. Second curve, you press enter. Okay, and the next question it asks you is to guess. So you want to move your cursor as close as you can to the point of intersection. And then you press enter again. And then it will tell you the point of intersection. So it says 17.672 y equals 2. So remember, the x value is your answer. Okay, so that's a way that you should have already known, or this is a refresher of a method you do. Now we're going to learn a new way. So the new way is to take the log of both sides and use the same base log as your exponent. So here's our equation again. We already know the answer for method 1, but I'm going to show you a new one. So what you're going to do is you're going to so if you remember, like, solving equations, you can often do whatever you do to one side of the equation, you also you do to the other, and it'll keep it the same. So you can do that with logs. So you can take the log of both sides, and in this method, we're going to take this log of the same base as the exponent. So the base of the exponent is 1.04. So we're going to take log of 1.04 of the left side and log base 1.04 of the right side. And then what happens is on the left side, the log base, and the purpose of choosing that is because now log base 1.04 cancels with the base of 1.04, and you get just x on the left side. And then on the right side, you get log base 1.04 of 2. And then from there, you just find what log base 1.04 of 2 is with your calculator, right? So to do that, reminder, you press the math button, right? You get this screen, and then you want to scroll down to A where it says log base, right? And press enter, all right? And then you get that screen, and then you just want to type in 1.04 for your base and 2, and then you get your answer, 17.6. Next method is you can take the log of both sides and use any base you want. So method 2 and 3 are like totally acceptable. Method 2 you would typically use to solve by hand, right? If you didn't have a calculator. And this method you usually use if like you have a calculator. But yeah, those it doesn't need to be that way though. So here's our original problem, right? So we can take the log both sides using any kind of log, but just for the purpose, like we're going to use log base 10 because it's the log button in our calculator. So here's our calculator, right? The log button is right there, right? Remember that means the log base 10. So then we take the log of both sides, and then the way the power property works is now the x comes down from the exponent, and you get x times log of 1.04 equals log of 2. Now, log of 1.04 and log of 2, right, are numbers, right? We know because there's no variables in those. So you type them in the calculator and you get these gross numbers. So what we're going to do is we're going to isolate x by dividing both sides by log of 1.04, right? And we get x equals log of 2 over log of 1.04. And then we just type that in our calculator. So remember, up there is log base 1.04 of 2, 17 point. That's the answer we should get. And then that's from the previous problem. And then you type in log of 2 using that log button divided by log of 1.04. Right? You type that in. And then you get... So I left the previous problem on there so you can see they are the same answer. So x is 17.672. Okay. Okay, so now we're going to use what we had just learned and do some examples. So solve the following equations, truncate the answers to 3 decimal places. So here are exponential equations. So we're going to do some more examples of the methods we just learned. I'm going to use method 2 for all of these, by the way. So since the base of the exponent is 2.25 in problem A, you're going to take the log base 2.25 of both sides, right? You get this. And then the right side, right, just becomes x. And then you just plug the left side in your calculator, and you get 1.984. Okay, I'm going to have you try this one on your own. So solve for x for b. Okay, so you use log base 3.5 because that's your base of the exponent. And then the left just becomes x. And then you plug the right side in your calculator and you get 1.838. Now for C, it's a little different. It's probably best if you just divide both sides by 2. So you get like, it looks like the starting of the other problem. So you divide both sides by 2, you get 8 to the x equals 64. And then now you take the log base 8 of both sides, and the left side just becomes x, and log base 8 of 64 is 2. Right? You can also solve this problem with powers of 2 or powers of 8 after you solve them. So you can actually do this one without your calculator, but I'm just practicing solving with logs. Okay, now this is really important. So A, B, and C, as you notice, the variable that we're trying to solve for, x, is in the exponent, right? Like, right, you have 2.25 raised to the x, right? But for D, the variable we're trying to solve for, x, is not in the exponent. So for A, B, and C, you have to use logs or some kind of like fancy manipulating of the equation by like making them all have the same base or things like that. Logarithms will work like every time, right? But when x is in the base of the exponent, you do not need to solve for logs, right? So you just divide by 2, and then remember to undo the number exponent there, you just take that root. So it's like the 8th root of both sides, right? And then you just get x on the left, and then it's 8 root of 64, which is about 1.681. So that's really important. You know, if x is in the exponent, to solve it, you probably need to use logs, right? And then if x is in the base of the power, you do not need to use logs. Okay, so summary. Solving exponential equations using logarithms, right? So you want to take the log of both sides and then use the power property of logarithms. And remember, the power property of logarithms is log base m to the n equals n times log of m. All right, hope that was helpful. Thanks, bye.